Why did you keep moving? Why would I move?
So, let's just do a quick reminder, a couple things that I found out today and things I just want to remind you about. Number one, your test over Chapter 7 and parts of Chapter 8 is when?
Monday.
Monday. Okay? Next Monday, right? So that would be the 25th, if I'm doing my math right. Okay. So Monday, January 25th is your test over Chapters 7 and parts of 8. Next Friday is your final exam. The final exam will just count as another test. So it's a 100-point test, no bigger, no less. So you have 80% allocated to tests in this class. That means it will be evenly divided amongst your 4 tests, right? So 2 of those 4 tests are next week. So 40% of your grade is next week, right? Okay. All right. Now, the good thing about that is if you tanked on one of our previous tests, there's still a lot of room to grow, right? So there's a lot of ways to improve your grade. All right? Yes, you could also go down, but yes. Yes.
Are these like good scoring tests?
I have no idea.
Oh, yeah. I bet they're really hard.
Okay. So that's that. You have your take-home quiz for the week, so that's good. And there was one other. Oh, core. This Thursday, I will do a core session in this room as a review for Monday's test. So I've put it open with 35 seats, but even if it's full and a few people want to stand in the back or something, that's fine. Okay. And then next week, Thursday, I think this is a little unusual, but supposedly we are going to have core again next week, Thursday. So if we do have core next week, Thursday, then I will again have a core review session, which would be to prepare for the final, right? So there you go. Now, if you attend a core, that's not instead of studying, right? The core is in addition to your own studying. There's only so much you can do in 40 minutes of core, right? So there you go. Okay, so let's get into today's lesson. So very quickly, we're going to walk through the problem of the day. This is a review of identities. You will need to know these in order to be able to do the homework problems tonight.
Right.
All right, so anyone know what sine squared is equal to? 1 minus cosine squared. And no cosine squared equals? 1 minus sine squared. All right. Sine 2x, double angle for sine.
2 sine x.
2 sine x cosine x, right? Yes, okay. Okay. Can anyone name any of the double angle identities for cosine?
1 minus sine x squared over cosine.
Let's see, you're close.
It's 1 minus 2 sine squared.
Okay, that's one of them, right? Oh, that's that one. That's that one. The main one is cosine squared minus sine squared. Right? Okay. So yes, cosine 2x equals cosine squared minus sine squared. It also equals 2 cosine squared minus 1, and it equals 1 minus 2 sine squared. Now to get these, you're just taking this and replacing the cosine squared with a 1 minus sine squared, or the sine squared with a 1 minus cosine squared. Okay. Why do we need these? We're going to use these to get these. So we already know sine squared is 1 minus cosine squared, but if you look carefully at the double angle identity for cosine, we could also solve that for sine squared. If we solve this for sine squared, we get sine squared is 1/2 of 1 minus cosine 2x. Similarly, if we solve this one for cosine squared, we get cosine squared is 1/2 times 1 plus cosine 2x. Yeah, I'll move it up for you. The formulas are almost identical. The only difference is sine you subtract and cosine you add. tan squared. Anyone know how tangent squared relates to secant? It is sine squared over cosine squared.
It's sine, so it's 1 minus cosine 2x.
Oh, tan squared x plus 1.
No, you're asking tan squared.
Oh, I'm asking just in terms of secant though.
1 over.
Oh, 1 minus
It's
sine, 1
secant
minus secant
squared
squared.
x minus 1.
Secant squared minus 1.
Oh my
Pink sheet never fails, yes, except you won't get to use it, right?
Oh,
Yeah.
yes.
God.
All right, and then secant squared, of course, is tan squared plus 1.
Wait, how'd you get secant squared?
How do I get these two? These are from
How'd you get tan squared?
this one. If you take this one right here and divide everything by cosine squared, you get tan squared equals secant squared minus 1. All right. Are you ready? All right. Here we go. Whoops, that's not it. These are the homework problems from Thursday night that I went ahead and put into today's lesson since Friday we didn't have homework. All right, so today we're doing 8.3 Part A, trig integrals. Now you think you might know all the trig integrals. You should know the integral of every trig function to a single power, right? Sine, cosine, tangent, secant, cosecant, cotangent. You should also know the derivatives backwards, right? So secant squared, secant, tangent, cosecant, cotangent, right? All the derivatives backwards. And actually now you can find the integrals of arc sine, right? Arc, secant, arc, all of the arcs using integration by parts, right? So you can find the integral of just about every trig function to a single power. Today we're going to do integrals of trig functions not to the first power. And it's a little trickier than you might think. So here we go. Okay, so if you research, either just by reading your textbook or by reading online, looking at other websites, watching YouTube videos, whatever, if you research how to do the integrals of trig functions raised to powers, everybody is going to tell you the same kind of thing. It depends on if the powers are odd or even. So we're just going to talk sines and cosines first. If you have an odd power for either function, you're golden. All right? So if you've got an odd power, if you have odd times even, just an odd power, right? Anything, as long as you have an odd power in there, then the problem is pretty straightforward, cut and dry, and I will walk you through how to do those. It's when you don't have an odd power. So if you have just, sine squared cosine to the fourth, or sine to the sixth cosine squared, or even just sine to the fourth, right? If all you have is even powers, it's a whole different ball of wax. So we're gonna start with odd powers. So here's the thing, we're gonna start with this one, sine to the fifth, cosine to the fourth. All right, so what you want to do is take a function that has an odd power. If they both have odd powers, it doesn't matter which one you pick. It's just honestly potato, potato. But if one of them has an odd power, then that's the one you have to pick. That has to be your function. So for this one, we have to go with our sine because the sine function is the one that has the odd power. And what you're going to do is you're going to pull one sine apart, and you're going to use that later on as your du. And then you're going to convert all the rest of them to cosines. So we pull one sine out. And we're left with a sine to the fourth and a cosine to the fourth. So I've just rewritten sine to the fifth as sine times sine to the fourth. Now, what you want is you want one trig function to the first power and then you just have to convert everything else to the other trig function. So the cosines are fine, these sines have to become cosines. So how can we rewrite sine to the fourth in terms of cosines? Well, how could you write sine squared? 1 minus cosine squared, right? So sine to the fourth is just 1 minus cosine squared squared. So we have, this is the integral of sine times 1 minus cosine squared squared. What's going to be really fun tonight is if you like distributing, you are so in luck. So, because there's an awful lot of it in these problems. So the next thing that you have to do is square out the binomial. You just have to get all the cosines put together, basically. So go ahead and take a second, square the binomial, and then you're going to distribute in the cosine to the fourth. Yes?
Do we keep the sin x at fun stuff?
Sine x just stays by itself, yep. And even though the camera is rolling right now, don't be afraid to talk amongst your group. And it's okay. Any questions on just the distributing? It's just algebra. Once you have your function rewritten so that you have one of them to a single power and then all the rest of the terms are in terms of the other trig function, now you do a u sub. Alright, so you let u equal whatever function is in here, just to the first power. So if your u is cosine, what's your du? What is it? Negative sine x dx. So what you end up with here is you end up with the integral of, well, that's just u to the fourth minus 2u to the sixth plus u to the eighth. And then your dx, your sine x dx equals negative du. And now you just do power rule. Make sure you plug your u back in. You ready to try one?
Of course.
A U try. There we go. Does everyone have this? Okay. All right. So the U try that I had was this one, let's do this one first, and then we're gonna back up. So, third period gave me a hard time because I had an odd even, and then my U-try was another odd even, and they said, well, what if it doesn't work with an odd odd? So we did an odd odd just to prove that it would work. So we'll do an odd even first, and then we'll back up and do an odd odd. All right, so take a minute, see if you can try this. What function is gonna be the one that you pull a singleton out? Cosine, good. Oh, and I have some stuff to hand back to. These actually belong to you until you're ready to go. Do you have these? You have yours, right? Yes, okay.
If you have a horizontal shell, that's what you do always. But washer is going to be dx, just do washer. Because if you're going to do shell, when you do your right hand side, you have two different rights. And a left, so you actually have to break it up into multiple particles, one from here to here, one from here to here. It's really complicated, much easier just do washer.
All right. So let's walk through this. You pull out a cosine. And you're left with sine squared, cosine squared. All right, what function, if this is cosine, what do all of those have to be? They all have to be sines, right? So you're going to replace, the sine can stay sine, but the other cosine has to be replaced with a 1 minus sine squared. All right, what do we do next? Claire, what do we do next? We distribute, right? So you end up with sine squared minus sine to the fourth. Good. Naomi.
Hi.
Hey, how's it going?
Good, how are you?
I'm doing okay. What should we do next?
Do a U sub and the U is gonna be sine x, or
That-
sine 4x.
That was beautiful. You are exactly right. Okay, so Devin, what is the derivative of, are you okay?
Yeah.
What is the derivative of sine 4x?
Is it 4 cosine 4x?
Was perfect, yes. Why is it not just cosine 4x? Does anyone remember the rule for derivatives? Chain rule, right? Got multiplied derivative. Okay, so now that we've done our u sub, so we get, this is going to be 1/4. So we end up with 1/4, the integral of, so we have u squared minus u to the 4th du. So you end up with, this this is u cubed over 3. I'm going to go ahead and distribute the 1/4. So you have 1/12 u cubed minus 1/20 u to the 5th plus c, and then we plug our signs back in. 1/12 sine cubed. And of course, you can pull the 1/4 out. It's fine, either way. Minus 1/20 sine to the 5th. How'd you guys do on that? Yeah, lots of thumbs ups. Good. Okay, so very quickly, sine cubed, cosine cubed, when they're both odd, you do it the exact same way. The only difference is you can pick whichever function you want to pull the singleton out for. So which one do you want to pull out? Sine. Okay. So if we do this, now I'm going to zip through this because we have to get on to the next thing. So if we pull out a sine, and we're left with this, what does the rest of it need to be in terms of? Cosine. So how am I going to get a cosine, Alex?
Are you doing cosine there?
Yeah. So I'm going to replace the sine squared with a 1 minus cosine squared, right? So I have a sine x times, so this is 1 minus cosine squared times cosine cubed dx. Good. Gulab, what do I do next?
I use up the cosine.
You're very close, but that's 2 steps down. Before I do a use of, what am I going to have to do in here?
Oh yeah, I'll put those together.
Yeah, I'm going to have to distribute, right? Okay, so I have sine x times cosine cubed minus cosine to the 5th. Now, what do?
I use up.
Use of. So my u is cosine. Vincent, what's the derivative of cosine?
Sine x.
Which one?
Negative sine x.
Yes, there it is. Negative sine x dx. Okay, so this one ends up being, so we have negative the integral of u to the 3rd minus u to the 5th du. And I'm going to go ahead and put the negative in, so we get negative 1/4 u to the 4th plus 1/6 u to the 6th plus c. So our answer is negative 1/4 cosine to the 4th x plus 1/6 cosine to the 6th x plus c. If I had picked the other function to pull out, I would have had a completely different answer, right? But they would be equivalent, right? Remember, sine and cosine are really the exact same function, just shifted by a pi paths factor, right? So you can end up with equivalent functions that are just slightly different, so all sines or all cosines. Good. All right, moving right along. All right, one more. And I want you to see if you can try this. There are no cosines. Dun, dun, dun. Right?
Christ. What are you doing?
The problem with the use of is your du would have cosine in it and you'd be stuck. Yep.
you just do a U sub. As long as you've got this is sine and everything else in terms of the other function, then you do cosine and see what happens. What's the antiderivative of 1? So it's okay, except it'll be U, but yeah. You're on the right track. You are doing it beautiful, except when you differentiate 1 with respect to U, the antiderivative of 1 would be U, not X. So yeah. I think it is. So he wins. Okay, because it is all of these, right? Yeah. Okay, so, Chris, what did you do next?
Change sine squared x to 1
Good. All right, Ashley, what'd you do next?
I had U as cosine X.
Very good. So don't let the 1 freak you out. As long as you have a singleton sine or cosine and all the rest is in terms of the other function, it's okay if there's constants there. So we let our U equal cosine. So Ashley, what was your du?
Sine X dx.
Okay, so what you end up with here is the integral of, so this is 1 minus u squared, and then sine x dx is negative du. Yes?
Is it actually called sine?
I don't know, that's just my word.
This
I don't know. I think singleton is a word, I don't know, is it?
Probably is.
Is it? Thank
It's
you.
probably
It's probably not. I don't know. All right, if it's not, it should be. So here's the problem. The antiderivative of 1 du, is it x or is it u? It's u, right? Okay, so this is negative u plus 1/3 u cubed plus c. So you end up with negative cosine x plus 1/3 cosine cubed plus c. All right, all odd power combinations are pretty much the same. All right, so pull a singleton out, right? Get all the other powers like in terms of the same other trig function. Get them all multiplied together, u sub, and you got it. Now let's move into evens.
Let's do it.
What?
Okay. When all of your exponents are even, you have to get them not even anymore. Okay? So, so the way that we're going to do that is we're going to apply those identities that we figured out on the first page. These down here. These are actually thought of as power reduction identities because if you look at it carefully, you start with a squared and you end up with a first power, right? So we can take sine squared and end up with a cosine to the first, or we can take cosine squared and end up with a cosine to the first. The problem with these is that when you apply them, you have to double the angle because they're based on the double angle identities, right? So when you double the angle, all of your angles had better be doubled because you can't do cosine x times cosine 2x and put them together without using yet another identity, right? So unless you want to use your product identities, your product sum or anything, something like that, instead what we're going to do is just convert everything to the double angles so that we can then multiply them and distribute. So, oops. Here we go. Okay, so we're gonna walk through this one. So when we do this one, and really I could have put this all in the first step, but so I've done multiple steps. It's gonna look like it's really long, but it's not quite as long as it looks like. So the first step is we're gonna change our sine squared to a 1/2 times 1 minus cosine 2x. So the problem here is we have a 2x and we have just an x. So now we're also going to convert the cosine. So the cosine to the 4th, think of it as cosine squared squared, right? Cosine squared is 1/2 times 1 plus cosine 2x, and then we square it. So we have 1/2 times 1 minus cosine 2x times 1/2 times 1 plus cosine 2x squared. Two things to be careful about. First thing to be careful is not to confuse your 2x with squared x. Be very distinct between your exponents and your arguments. The other thing to be very careful about is your parentheses. So, for example, when we're squaring this guy, make sure you're also squaring that half. All right. So, what I like to do is pull all the coefficients out front. So, if I pull the coefficients out front, what number actually goes out front? 1/8. Very good. And then this, we're going to square this guy. So you get 1 plus 2 cosine 2x plus cosine squared 2x. What's the only really good thing we could do next? Let's do more distributing, right? Yay! Distributing.
Is this like the long way to do it, or when we shortcut tomorrow, or is this the only?
No, this is it.
Okay.
Yeah.
You can change that a minute to start working.
No, you could be the
I'll be the
one.
one.
Shortcut.
I'll
You could be the one. There actually is a formula, but it's just basically doing all of this and memorizing how all of the output for all the possible combinations, right? So, yeah, it's a very it's convoluted formula. Yeah. All right. It probably won't work because that cord is not connected. Remember, let's try it. It's dead. My cord is dead. Oh. I just figured out why the cord is dead. It's not even plugged in. It's just like hanging. But I've got to unmount the phone. I got to figure out how to do it.
It's just got a little.
There it is.
It's like putting in a USB.
All right. Well, if they call back, maybe it'll work. Okay.
Who would
All
have
right. Who would have done that? No one in this class. All right.
Shreyas.
1 plus 2 cosine 2x plus cosine squared 2x, and then multiplying this term, so minus cosine 2x minus 2 cosine squared 2x minus cosine cubed 2x. All right, and then of course, the nice thing about this is there are some like terms you can combine. It is not terrible. There could be worse. Alright, so we have a 1, and then we have a 2 cosine 2x and a minus cosine 2x. So we end up with plus cosine 2x. And then we have a cosine squared and a minus 2 cosine squared. So we end up with minus cosine squared. And then minus cosine cubed. Now, what I did last class was I kept the 1/8 out front, and it backfired a little bit. So honestly, just for clarity, I'm gonna go ahead and distribute the 1/8 in. So here's the thing. This we can anti-differentiate. This we can anti-differentiate, right? This guy we can rewrite using another reduction formula, get it down to a first power and anti-differentiate. But this guy, cosine cubed, why, we know how to do it because we just did it in the last slide with sine.
How long is this problem gonna take?
It's a big problem.
We have like 3 homework problems from that, so I'll take an hour.
Let's just say, like, more than half of your homework problems are odd powers. So it's not so bad. Okay, so here's what I'm gonna do. Okay, I'm gonna rewrite this first. And I'm gonna go ahead and multiply the 1/8 in. Cosine squared 2x is the same as 1/2 times 1 plus cosine 4x using the power reduction formula. And then minus 1/8 cosine cubed. So we can integrate all of this, no problem. And then that guy, we're going to go back and use the method that we learned 5 minutes ago. So let's go ahead and integrate what we can first. So this is 1/8 x. Antiderivative of cosine 2x. Ignore the 1/8 right now. Antiderivative of cosine 2x. What's the antiderivative of cosine x? Sine x, right? Antiderivative of cosine 2x. 1/2